Hello, welcome. My name is Daryl. So glad that you're joining us here in our session today called Integrating Coding into Any Subject. We are a curriculum development panel. So all five of us work together and we create curriculum every day. And so that's what we do. We use Scratch every day. And we've been working with schools and districts to get coding into all the different subjects that they're already teaching as well. So we're so excited that you're here and joining us. We have a lot to share, but first we'd like to see if we can get a little bit of input from everyone to get our minds into other subjects that we teach. And so go ahead and you can scan this QR code, or you can go to slido.com and another tab in your browser, and you can enter that what is it, 7-digit number to go ahead and join this poll. And just would love to see and hear what everyone's favorite subject is to teach out of these four options at least. So is it math? Is it social studies and history? Is it science, or is it language arts? All right, here we go. So we've got a lot of participants here jumping in. All right. Thanks, y'all. So, wow, math and science are going neck and neck there as we see the last results coming in on this poll here. And so I'm a little surprised. I was sure it was going to be science, but it looks like we got a lot of math and science fans. Oh, and there's science popping up to the top. Great. Well, we're going to get to talk a little on pretty much all of these subjects today. And so I just wanted to do some quick introductions about who we are. So my name is Daryl. I'm our elementary curriculum lead at CodeHS. And so I have the privilege of getting to lead this amazing team. I started out teaching 6th grade elementary. So that's around 11, 12 years old here in the US. But that was still elementary, so contained in one classroom. After that, I shifted over and started teaching all K through 5 and sometimes K through 8 grades for STEM and makerspace, and that included programming as well. Then I jumped into curriculum development and computer science curriculum development. So I'm going to go ahead and hand it off to each of my team to do a quick intro. Also, I'm based out here in not quite yet sunny California in the US. And it's nice and early, but I'm fully energized. So let me hand it over to Lisa.
Hello, I'm Lisa. I am an elementary curriculum developer with CodeHS, and I also have a background in the classroom. I taught 1st grade for several years, and then middle school, and kind of integrated coding into different subject areas that I taught. I am based in the very sunny Florida, and so my day has already started. I'll pass it over to Jennifer.
Hello, my name is Jennifer Mahan. I'm also a curriculum developer. I was a teacher for 10 years. I started teaching special education, 6th through 9th grade. I taught 5th grade math and social studies for a few years, which social studies probably being my favorite subject to teach, before I took over as a computer science STEM teacher and technology integration specialist. I am located pretty much in the center of the United States in rural Kansas. And I'll pass it to Sandy.
Thank you, Jennifer. I'm Sandy, and I'm also an elementary curriculum developer. And my background is not in the typical classroom. I taught first through fifth computer science for 11 years, and then I taught sixth grade computer science for 2 years. And so I'm actually very excited to be able to work with the core subjects now and computer science. So this is an exciting thing for me. And I live in northern Wyoming. Excuse me, Wyoming. So, Katie?
Hi, my name is Katie Williams. I am also a curriculum developer. I have a background in teaching fifth grade, also teaching STEM and gifted and talented students. I am based out of San Antonio, Texas. And if I were to pick a favorite core subject that I really love integrating computer science into, it would be a toss-up between math and science.
Awesome. Thanks, you all. We are super excited to get to present to you a lot of our experiences of working together as a team to develop curriculum that we can integrate into all subjects. So let's take a quick look at our agenda for this session, for this hour. And so we're going to first talk a little bit about the work that CodeHS has done in integrating computer science into subjects and working directly with schools to get their students being able to code while also doing math, science, social studies, and language arts. Then we're going to have each of our panel members here share a sample project that they worked on to give a picture of what it looked like for them to actually integrate it and how the computer science and actually mutually benefits the core content area. And we'll also talk about some maybe guiding principles as you design lessons and as you think about how you want to integrate Scratch into your classroom and with your students. After that, we're going to do something a little bit fun. We're going to kind of do a live brainstorm around around a core content standard. And I'm going to have each of you who are participating go ahead and try yourself as well to think about how would I actually integrate computer science into this. And then we'll do some discussion. We'll have, hopefully everyone will just be jumping in the chat, talking about their ideas, and each of us will talk about our ideas as well. And then we'll just open it up to Q&A as well as talking through some ideas that you might have on the next slide when we poll you about what you're interested in integrating computer science into. Lastly, we're going to share with you some extra resources that we want to give to you to help you as you continue your journey of integrating computer science into your classrooms. So with that, I want to go ahead and open up the chat for this question. What is one subject, concept, or standard, if you work in a standards-based environment, that you would love to integrate programming into? And be as specific as you can. So think back, maybe a recent project that you worked on, or maybe something that you've been teaching for a while and you really want to do it a different way, or maybe a more engaging way. Maybe something that your students have a hard time with, and actually using computer science and the way to think in algorithms and the way to think with code could actually be something, there could actually be a better way of learning that. I'd like you to go ahead and think about that and throw that in the chat. We'd love to hear some specific things that you are interested in. And we're going to try to address some of these during our Q&A later on as well. So I'm going to go ahead and give you a minute or two to go ahead and put in the chat what you'd love to investigate or explore more about integrating computer science into. Great. Thanks for starting to throw in some of your ideas. I see some science and some math and some art. Lindsay's interested in how research could be related to computer science. Oh, these are great topics. We'll give you just a little bit more time, but you can feel free to throw them in the chat even as I move on to the next slide. These are awesome. We want to get to try to talk on some of these later on during the panel. All right, lots of math, social emotional learning. Spreading of a computer virus. Ooh, that'd be an interesting simulation. Entrepreneurship. Wow, this is an amazing range. This is really exciting. Francesca's got to vote for AI. All right. Reading. All right. Someone's got some language arts in there. Great. Cybersecurity and animation. This is an awesome list. Thank you all. This is great. You're welcome to continue adding those to the chat, but we'll go ahead and continue on, and we'll definitely try to get to hit some of these topics to talk on together during the interactive panel portion. All right, cool. So just a little bit more of an introduction and a little bit more about the work that we do and what we'd like to share with you about it. So CodeHS is, we're a company based here in the US, and we are a full K through 12 computer science solution. We offer professional development and support to fully help a district or school be able to implement computer science throughout all of their students and throughout all of their district. We offer both a specific computer science pathway, but also a specific whole for all K through 5 for the entire school year, interdisciplinary pathway, so that teachers can be integrating computer science throughout the year, all the way K through 5. We use both Scratch and Scratch Junior integrated into an online platform. We started working with elementary schools a few years ago in just 4 pilot districts, where we worked very directly with those 4 districts in very different contexts across the country, and trying to meet their specific needs and work with their specific standards to integrate computer science with them. And now we're serving districts and schools across the country and internationally also. We're in a few other countries as well, and we are having a great partnership with a lot of different schools and a lot of different places in the world. That's a little picture of us this year, actually, doing a school visits trip along with some of our other CodeHS team members as well. And so we actually got to visit classrooms, seeing our curriculum put in action. We have around 100, we've developed around 150 lessons together in math, science, language arts, and social studies. And so this is a GIF of me scrolling through our library of lessons. And we use Scratch Junior for K through 2, and we use Scratch for 3rd through 6th. And we our focus as we develop each lesson is to review core concepts and then integrate computer science control structures and skills into their interaction with those concepts. So with that, I'd like to share some samples. I'm going to hand it over to Lisa, and Lisa's going to talk about a lesson that she created. This might inspire you with some of the work that you're doing with your students, and just give you an idea of the different ways that computer science can get integrated. So take it away, Lisa.
Sure, thanks. So this is a math lesson created for upper elementary, so grades 3 through 5th or 6th. Called House Design with Area and Perimeter. And this lesson was created based off of a math standard, which says apply the area and perimeter formulas for rectangles in real world and mathematical problems. And so what this lesson does is it connects students with the career of an architect, so planning the design of a building. And specifically, students are planning for the sizes of different rooms that can go into a house. So that also connects with the real world process of planning out spaces. And this also allows for student creativity, because in the lesson, they get to eventually design their own house. and share the area and perimeters for each room in the house. Students are using functions in this lesson. So there's a function called draw room that they can then input the width and the length of the room in, and then the program will draw that room. And it also allows for teachers to give students additional math problems to solve. For example, one of the math problems that is provided in this lesson is Kathy wants a bathroom that is 7 feet long and has an area of 56 square feet. Find the width of the bathroom and draw it using the program. So that's an example of a math one that can be used in upper elementary. I'm going to pass it off to Jennifer now to share a social studies lesson.
Hello. So this is a state project that I created for 3rd through 6th grade. In the US, it is a standard for most 4th grade classrooms to learn the US states, specifically probably the state you live in. So this lesson aligns to the standard: use digital tools to research, design, and present social studies concepts, understand how individual responsibility applies. So this is aligned with that. So the first thing I did when creating this lesson is I uploaded all 50 state outlines into the backgrounds. So we provide the US map where students can locate their state, and then they can create an interactive project based on their state. So this example provides opportunity to show where the capital is, different state facts. So it's students creating an interactive activity, but using those CS skills as they work. So here's some of the blocks. It's a pretty simple program, but it's more or less students focusing on what are the state facts, how can I make it interactive, and how can I make it more engaging than maybe your typical poster board presentation in the front of the class. So this is just my take on a generic lesson that most students are doing in 4th grade social studies classes. So it took a lot of time uploading all of those backdrops that you can see right there, but that way students can customize it to their specific state. This allows students to show their creativity. It emphasizes skills like geography, research, and definitely showing mapping. They have to be able to locate their state or the state they're presenting on. So that's my 4th grade state project, and I'm going to pass it along to Katie.
Hello, I'm going to talk about an upper elementary project that I worked on that is to reinforce positive and negative numbers for students. So it hits a 6th grade standard in the United States, which is to understand that positive and negative numbers are used together to describe quantities that have opposite directions or values, and then also applying those to real world sort of contexts. And so one of the things I really like to do is integrate the math into CS because it works so seamlessly. So here, the numbers are being tracked with variables as far as the elevation goes for the bird. And it's really easy to see those positive and negative numbers. Here you can see that the bird's mouth is closed when it's above the 0 line, and then it's open to try and eat that fish when it gets down. And so it layers in those math concepts while also being able to use the coordinate grid for that. So I really like to integrate things that make sense. Like, not every standard is going to make sense to integrate CS into, but I think that there are some that lend themselves really well to this. And I'm going to pass it off to Sandy.
Thank you, Katie. And the lesson I'm going to talk about is a kindergarten lesson, and it's actually in Scratch Junior. It's comparing organisms, and there's some standards out there. Describe and compare the physical features of common living plants and animals. Obtain, evaluate, and communicate information. Compare the similarities and differences in groups of organisms. And so for kindergarten, it's a unique challenge. And what my so this lesson integrates computer science and science, and the student is going to demonstrate an understanding of comparing those features. And what my approach was, looked at the standard, looked at the grade level, and considered, the age, the length of the lesson, and so on. and then developed a program that the students can actually be successful on, and enough guidance that they could do this. I also really looked at the fun factor to make it interactive, so that the students, once they create it, they can actually make something happen and see the results. This lesson can also be expanded to include, not just the colors. This is the simplest, but they can also integrate this or expand this to include plants or other animals, other features of the animals, and so on. So that was my approach, and send it over to you, Daryl.
Great. Thanks, Andy. All right, great. So hopefully some of those ideas actually may even have related to some of the many awesome ideas that you all put in the chat already, and helped you kind of think about some of the different approaches that we used in both Scratch and Scratch Junior to be able to integrate computer science into each of these different subject areas, from social studies all the way to math and science as well. I want to go ahead and kind of zoom out a little bit and go over some of our approaches and some of our considerations as we're developing computer science curriculum integrated into other subjects. We want to help you be able to kind of think through, how do I kind of make those connections, and how do I create those mutually strengthening lessons where the computer science and the programming can actually help support the learning of the core concept, and likewise the other way around. Maybe the core concept really helps to illustrate or visualize or manifest what's happening in the programming. So, for example, if you're looking at something related to cause and effect, when something causes something else to happen, maybe in social studies, maybe in science, then this is an opportunity to consider, oh, maybe I can talk about using events, using a click event to help the user to be able to cause something else to happen, or using a touching event, like when the sprites or the characters bump into each other, then that causes something else to happen. That really highlights that interaction of something causing something else to happen. Similarly, if you have anything that works in cycles, of course, we'll often be teaching about life cycles or rock cycles or other different types of cycles, natural phenomenon that we see. Cycles can appear in math as well. Those are opportunities where we can consider thinking about loops. Would it be a forever loop? Is it some type of cycle that we see that continues on and on? Or is it a cycle that happens for a certain number of times? Those are the ways that we can integrate loops into some natural phenomenon that repeats itself. When we think about making choices, that's when we can we can often integrate conditionals. So when someone needs to make a choice about a certain scenario, it can be checking to see if something is true. And then we'll be having the program or the user of the program be able to navigate using conditionals what happens next in the program. It could be kind of like a choose your own adventure, kind of like part of the theme of this conference. Is when we might want to consider using conditionals. When there are repeated actions or procedures that, let's say, a person or an institution might need to take, that's when you can consider using functions. You'd want a function to be able to repeatedly do a certain type of process. Let's say it's part of the government. We have a government lesson that we created where which parts of the government will do which type of thing. That might be something that we might want to use functions for. If you have a certain type of value that needs to change its value, that's when you can use variables. That can often be handy in math, but in other areas too, keeping score. Also, any other changing values of phenomenon that happen in the real world, then that's an opportunity to integrate variables. And then when you're looking at comparisons, when you're looking at what's great, if something's greater than something else, if something is equal to something else, or if something just happens randomly. Those are different ways that you can use operators in Scratch. And those are the opportunities to integrate that into what type of program that you're using. So just as a real quick concrete example, one lesson that we wanted to do was about parts of speech. So noun, what's a noun, what's a verb, what's an adjective, how do those fit in? And so we were imagining, because this is not something that students are generally extraordinarily excited to practice, but how can we make this into a program that's exciting and fun to engage with, where students can actually learn more and also learn how programming can actually be something that helps them understand parts of a speech, parts of a sentence better. And so we're like, what if we did a random sentence generator? Because we know that there's different parts of speech that can be lined up in a sentence in English that will be able to create a sentence using random words that are each in the correct part of speech. And so that could have been a variables thing, but then we didn't want to confuse students too much with variables in using strings and things like that. So what we decided to do was make it kind of a cause and effect. So I want the user to be able to cause all of the words to randomly change. And then when we think about random, okay, random, well, there is an operator block for random. And so that started getting the idea of how to create a simple but effective program to start to integrate this into a fun way to program in Scratch. So moving on to another consideration, and we'll continue on with this example as well. Thinking about what types of projects that you could be creating in order to teach in another subject. I gave kind of a sequencing here, just an approximate sequencing of a level of complexity of what the code is going to look like. So if you want to do something simple and generally sequential, then you can just think about having an illustrative animation. That's often the simplest, and it can be the simplest way to illustrate some kind of phenomenon happening and in the world or in math or in science. And so just programming animation is already going to be a huge way for students to think about sequencing, thinking about decomposing a task or a procedure into its parts and actually programming them in order. The next level on top of that would be to create something kind of interactive for a user. So they're starting to think about a user and what they want to teach about this subject, what they want to teach about sentences to someone else. So putting them in the role of someone saying, I'm going to be displaying what is a noun and what is a verb by creating this program for someone else to interact with. So kind of like creating their own app or creating their own kiosk at a museum. This is a kind of a next level way for them to interact with programming in another subject area. And then in the most complex form, you might be thinking about how to create a game. And then when you think about game mechanics and the storyline of a game, then obviously that requires a little bit more thinking, a lot more creativity and open-endedness to that. And so you'll be wanting to maybe think about what kind of parameters that you want to set around that in order to help students to be successful around that. Or if you want to help them get started with some ideas of how to code it in order for them to not get too overwhelmed with awesome, huge imaginations that they might have around creating a game in a certain subject. And so for the parts of speech example, we decided to go ahead and go with kind of the middle of the road there, an interactive kind of app for someone to get to click on and create a random funny sentence. And so this is what it ended up looking like. And also along with that, I want to go ahead and mention something that I think is talked about a lot in the computer science education world, is to have that low floor and that high ceiling. So a low, easy entry point, and then a high ceiling that students can creatively take that project into many different directions and grow in how they're using that programming in ways that their imagination and their creativity takes them. And so we want to give them an accessible starting point. Sometimes we will give students what's called starter code. And so you could do that in Scratch by creating a framework for them to start coding inside of, maybe giving them some starter blocks. And that's what we do with some of our projects that we give to students in our platform as well. And that will more quickly scaffold and get them to the place where they're doing that computer science integration that hits the core content and that core concept around, let's say, cycles or around making choices more quickly. And so that can look like you sharing a Scratch program with them to upload and just have a starting point to work off of themselves. So this is our program that we created. And so in the this parts of speech project, what students would do is create all their 4 sprites for the 4 different parts of the sentence, for an adjective and for a noun and for a verb and for an adverb. And then the user would click the green flag to create a random sentence. And so at this point, as we develop this idea, then students, we're thinking about how is it that the students should be programming? Should they be programming all of it? Or do we want to give them some starter code so that this doesn't take 4 hours for them to create this project? And definitely in this case, we wanted to give them some sprites to be able to already work with, so they're not kind of getting lost using half the class time picking which sprites they want to use. But we did want to let them pick the parts of speech that belong to each costume, and then also have them actually create the code, because it ended up being really simple code. And this is the power of events, so that each of the sprites would have a when green flag clicked block, and then they'd be able to do that same block for all 4 sprites, and then have it switch to a random costume. This is probably the trickiest block that we taught them, which is to pick random, which is a really powerful way for them to be able to get random numbers and random silly sentences. All right, so with that, hopefully those were some helpful considerations as you integrate computer science into your subjects. We're going to move on to a live brainstorm. And so what we wanted to do here is actually have you and us on our panel think through how we would actually integrate computer science into this specific standard. So this was a request that was given to us from a district that we haven't created this lesson yet. And I promise you, our team, we haven't talked together yet about this. And we're going to have you now spend 2 minutes thinking about this standard yourself and how you might consider integrating programming into it. And you can even get yourself into Scratch right now and start playing around with how you might do that. And then we're going to share live each of our independent thoughts here on our panel. And then we'd love to hear from you in the chat as well, what ideas that you have as well, so that we can kind of see different ways that computer science can interact with in this case, this science standard. So I'm going to set the timer. We'll have a little background music. Go ahead and I'll go ahead and read this for you, and then allow you to have some time to think about how you would integrate programming with this standard. So the standard is: construct an explanation that differences in the apparent brightness of the sun compared to other stars is due to the relative distance or scale of stars from the Earth. Emphasize relative distance from the Earth. Okay, so this is a standard basically about how stars that are closer are going to be brighter, and the stars that are farther are going to not be as bright in relation to the distance. So I'm going to go ahead and start the timer, and we'll then have a big share out together after the 2 minutes. back. I know that wasn't a long time, and normally we as a team spend way more than 2 minutes thinking about any idea. But we're going to go ahead and do a quick share out from our team. And as we do that, you're welcome to keep working on this integration idea yourself and maybe compare it with some of the thoughts that we have on how we might work on this one. To create a lesson for students to integrate programming into the standard. So I'm going to go ahead and hand it off to my team and go ahead and let's go ahead and have some sharing out. Let me go ahead and hand it off to Jennifer first. Again, we've never talked about this, so we're going to actually kind of have a short live chat right now around how we might approach integrating CS into this standard.
Great. So my thought was creating something where you add the sun and the stars and they're changing their size in relationship to distance, whether that's the earth or a sprite or just something with changing even like the brightness of the sprite if you're not changing the size. So that's kind of what I was thinking about.
Cool. Yeah. So maybe working with the costumes
Yes.
to show brightness changing according to distance somehow.
Correct.
Awesome.
Yeah, so to play off of that, I actually built a program, and Daryl, if you want, you can share it. If not, that's fine. But it's the same sort of idea. It's using the arrow key inputs. And so as the star is moving toward Earth, which I added as a sprite in the program, the star gets both larger. So I was able to use the looks blocks to make it change size and also changes brightness. And then as it moves further away, so using the right arrow key input, it gets actually smaller and dimmer, just to kind of create that model that students would be able to show their learning with.
Awesome. Sorry, I'm not sure if I'm able to share my screen right now, but that's okay. Thanks for describing that. Oh, okay. Oh, cool. And here we are. Awesome. And how should I interact with this program right now?
So it uses the right and left arrow key input. So if you tap just the green flag to start, the star dims. And then if you use your arrow keys, it gets larger and smaller. So it should, hit that standard pretty well.
Wow, you did this in 2 minutes? No, I'm just kidding. We all thought about this independently a little bit, but that's really cool. So I see, let's take a look at some of the code here.
So it's really simple. I mean, it's a 4th grade standard. And so really, as far as interdisciplinary lessons, I think it's important to, yes, integrate the computer science, but also integrate it in a meaningful, simple way. So they're really getting their core content area as well as the computer science. So the only code there is on the star because that's the one that's moving.
Awesome. Thanks, Katie. So I'm going to riff off of that actually real quick, and I'm going to share my idea that I had for this one. And so I actually like Katie's better, but this is a different approach. I actually didn't have the sun, nor did I have the earth as I should have. But if I had more time, I would put our CodeHS mascot Scout here on the earth to really hit that part of the standard. I wanted to do one where we actually could have, instead of the arrows, have the star here be draggable. So as the star is dragged closer to Scout, then it just gets larger. And this one would be an interesting math one because this part is the trickiest part to code. How do we get it so that the distance, when we get closer, the distance is getting less? Scratch has this awesome block already that calculates the distance to Scout. However, at that point, as the distance gets smaller, if we use that somehow, then it would have to the star would be getting smaller if we did it proportionately. So what I would challenge students to do is actually figure out how to create this block here. I wouldn't give this one to them. And what I did as I was playing around with it was, as I discovered, this is, around 520 steps away in Scratch. And so I would have them do figure out what this number is going to be. 520 minus the distance will get them to be able to have it scale as it gets closer to Scout. Cool. And then Lisa.
Yeah, so I also created a program, so you can open that link and share it too. I was looking a little bit more at stars that are kind of more stationary in the sky and focused in on the construct and explanation part of the standard. And so if you click the green flag, then you'll see the sun rises in the sky and causes all of this brightness that we call day, and it makes the other stars a little bit less visible. And then if you click the sun, then it goes away, and so the brightness is diminished and those stars appear. I also used the brightness setting for the sprites to change how each of those stars looks. So they're each a different brightness, and so students can go into each star. Maybe can you click the star on the farthest right? Sorry, from the stage. So yeah, right up there. And so then they can program each star and say, okay, well, this is the brightest one. So then it appears that that one is the closest to the Earth in this program.
Awesome. Wow. Well, that's really cool. So this is something that we all independently brainstormed. And then, yeah, does our team see anything in the chat that you want to highlight for what others had thoughts on for this particular brainstorm?
Yeah, Stephanie said when the green flag is clicked, she would go to a random position, set the size of, I believe, the sun to 150% to show that when this sprite is clicked, it would say, I am the sun. I appear very bright because I am much closer to the Earth for 2 seconds. So kind of a spin on what we're doing, but she's programming the sun. And that is a fun twist to this.
I like the random number idea too, because then they get to see a variety. They don't have to teach a user how to use the program, but it actually gets to show them just through using the program what different distances would mean. So I like that.
Also, a lot of people are asking for our links to these programs, and I think the best way to share them with you all will be to add them to our slide deck, and you'll be able to access our slide deck, and that way you can see the programs that we shared here.
Yeah, definitely. Please definitely take the slide deck with you afterwards, and we'd be happy to share those with you. Cool. If you have a Scratch program that you created in the last few minutes with some ideas around this, you're welcome to drop it in the chat also, and we'd love to compare our ideas. With that, we'll also like to go ahead and just start looking at some of the questions and ideas that y'all had put into the chat earlier, and kind of make this a little bit more of a live Q&A now time for us to get to answer any questions that you have about integrating computer science into subjects, as well as talking about some of the ways that we've done some of the integrations that you are curious about. And so I'm going to actually hand it over to Lisa to kind of point out some of the questions and suggestions that we got in the chat, so that we can actually start talking on some of these and sharing some thoughts and some ideas.
Yeah, definitely. So first, at the beginning of the session, you guys shared out several ideas of different types of lessons or integrations you would like to see. And so I know our team has taken a look at some of those suggestions, and we have lessons through CodeHS that actually integrate in with some of these concepts that you guys shared. So I see that, Jennifer, I see that you have one posted if you would like to share.
Perfect. If Daryl, you would like to share one of those AI lessons, that'd be great. So someone mentioned that AI was something they're interested in, and we actually have K-5 lessons all based on AI. And the fun thing about these is we made them friendly for that age. So if you're thinking of, say, a kindergartner learning AI, this example here is, I believe, 3rd grade. This is our machine learning face sensing using Scratch. The Scratch Lab students are able to explore AI and what that looks like with face sensing. We also have some unplugged lessons for kindergarten and I believe 1st grade. That's more of sorting data. And we understand that you're teaching AI, but not necessarily have to make it look like AI for our K1, 2 learners. So it's more of understanding data and how AI is using data to sort that information and to get better. We also have in 4th grade a program an AI chatbot where students are doing their best to program a little chatbot like program, and students can interact with it, ask questions, and if it doesn't know the answer, it'll say, can you give me more information? So students are kind of teaching the data as they go along. If you want to click the program on that one, so we can just kind of show that. So this is what the program looks like when it's finished. And this would be a few days worth of projects where students are, and this is actually programmed. If you want to click on that green flag right there, you can see our mascot Scout says, hey, ask me a question. So you can type something in there. If Scout doesn't know it, you will then program Scout to know the answer. So it's just like how we teach AI data, Scout's using data. So it's not an actual chatbot, but it kind of goes along there. So we do a lot with teaching machine learning and just exploring how data is used in AI. So just here's a few examples of how you can use Scratch with AI.
Awesome. Thank you, Jennifer. I would like to highlight a program as well. And Daryl, I've shared that link with you in our chat called Pair Programming, Create a Band. I saw some suggestions for integrating music. And so this lesson allows students to first learn about the concept of pair programming, and so work with another student, and also allows them to create their own sequence of music, and they can create a band with different sprites highlighting different instruments, and kind of use the keyboard to control the music in that way. And then in an extended version of this lesson, they can actually create their own song. So you can see, for example, in this program, the G sets off the guitar on the keyboard, the D sets off the drums, the space bar is the cymbals, and then the up arrow is the microphone. So as students use their keyboard, and Daryl, you can, go ahead and play some of those instruments on here. I think, yeah, the guitar and the drum, to see how it sounds. So there's a lot that you can do in Scratch with music. And so this just gives students a little bit of structure to explore that with. Okay, and I think we can go ahead and start answering some of your questions now as well. So we had some questions early on that may have been answered in the chat, but we'll answer them here as well. I did see someone ask if Scratch will ever use single sign-on with Google. That's not something that Scratch currently does, but CodeHS does use single sign-on. And so that's just an element that we provide. These lessons that we are sharing, we are going to have the program files provided for you in the slides, but we do offer all of these lesson plans and step-by-step instructions through codehs.com. So you can certainly join at CodeHS, get a license, and provide these to your students. I will look at a couple of these other questions, and if anyone wants to take one to answer. This one says, how do you structure the mechanics around the very first Scratch introduction in the classroom at the start of the year?
That's a great question. So yeah, we will usually recommend districts to have to set aside a few class periods to do some introductory lessons on Scratch or Scratch Junior to get students familiar with first how to get into the program, what are the parts of the program, and start getting to play around with some of the blocks before actually getting to integrating it. We don't want to overload them cognitively, and so that's definitely a consideration that we always recommend, and we help walk districts through. Here's the getting started for kindergarten. Here's the getting started for first grade. Here's the getting started for second grade, and can up it up a little bit more each grade level. How quickly that they start playing around with more of the complex concepts, but definitely recommend giving those introductions at the beginning of every school year so that they don't reach like a frustration level of the number of things that they need to process in their brains as they're integrating computer science with the core content.
Awesome, thank you. And Jennifer, would you like to speak on where lessons are located, whether in Scratch or otherwise?
Yeah, so the question is, are the lessons you speak of located in Scratch? Which is a great question. We actually have Scratch built into our platform at CodeHS. So we use what we call our sandbox, and that's where we actually build all of our lessons. However, in our slides, you'll find a link to what we call our sandbox, and you are able to access the project that way. It is a little different than the typical Scratch in the sense it doesn't have like the backpack and things like that, but you're able to still access those links there. So no, they're not in the typical Scratch, but they are in our version of Scratch.
Awesome. Thank you all. So there's a lot more suggestions. I'll try to go over a couple more if we end up having another minute or two at the end, but we did want to offer you a couple more resources before we start to close things out. And so I'm going to hand it over to Katie.
Great. So sometimes you're going to have a lesson that doesn't necessarily as intuitively go with Scratch, but you still want to integrate computer science into the lesson. And so for these instances, we created some design your own lesson graphic organizer templates, which is a really long title for what they are, but they are linked in the slides. And if we can open those just to kind of see what some of them look like. They are designed to be kind of like a grab and go sort of resource that can help you with whatever it is that you're teaching. And so we have like an interactive timeline template, and this is just a really simple template. It's designed with very minimal code blocks. I believe this one is designed with broadcast messages that kind of like open up the timeline part, and then it goes back away. And so students are able to kind of design it how their level of comfort with computer science is. And so they can simply go in and edit the boxes and just put text in, or they can make it spin and disappear and do all sorts of things. And so there are these templates that you can use whatever subject you're teaching, and you can just give the links to students. They can open them and remix them, and they can be used. Each slide has a little bit of like a suggestion of how you could use it, but really the sky's the limit, and you can use them in whatever way works best for you and your students. And I'm going to pass it off to Lisa now.
Okay. So I just wanted to share with you guys that we also have an expo booth. So if you go to the expo area, you can find a complete lesson with all of the resources, the lesson plan, starter code, and the finished sample code for a CodeHS lesson, choose your own path game that takes students into creating a choose your own path game that follows a specific culture that maybe they're researching or one that they are connected to. And so all of the resources for that lesson are provided for free if you visit the expo booth there. So yeah, hope to see you, and I will go ahead and bring back the rest of my team now.
Awesome. So we have gotten a lot of questions about how to access the CodeHS curriculum. We do work, we partner with districts and schools and around the world. And we help provide the full support in order to be able to implement computer science successfully. And so that includes professional development, implementation support, live support for teachers when they have questions or any issues. And so we are a licensed product. We're not here to sell to everybody, but if you are interested in CodeHS, that is who we are. And we wanted to give you some insight into our thought processes around how we create so that you can create also in your classrooms. If you are interested at all in finding out more about CodeHS, this is where you can go in order to learn more about what we offer. But we hope that you found this time useful. And we're just so excited for your participation and for your ideas. And we just have like a minute and a half left. What I can do is go ahead and go through some of the thoughts that y'all put into the chat, and we can talk about some of the ways that we integrated some of these. So someone had said research and note-taking. We created a research a research presentations project where students do research and then create a visualization of what they learned from the research in Scratch. And so we encourage them to be able to think about how the data should be visualized and how to make those connections using structures in Scratch. And so that's one way to think about integrating it with research, is how can they present their data. We have fractions lessons. I can't go over that one in too much depth, but we do have fractions lessons that talk about combining fractions, adding and subtracting fractions. Let's see here. Anything else my team wants to highlight in the last minute here?
We have one that shows how pollution affects the ocean, and it shows kind of trash going into the ocean and where that ends up. So we have projects that show effects of pollution.
That's right. I think we used a lot of events in that one to show the cause and effect for that.
Yes, and backdrops and costumes changing as well.
Yeah, awesome. Thanks, Jennifer. Okay, well, I think we're pretty much at time. Just want to thank you all again for attending. Thanks so much for being part of the session and participating with us. Please definitely use the slide deck, or at least use the recording to access these resources. And we hope that you have a wonderful rest of your conference. And thanks so much for your time.